This video is on heat maps as part of the demonstration videos in the course B08 on data visualization. We're going to use different packages in this part of the course. So please switch to RStudio now. So what we're looking at is a package called gplots, which allows us to draw enhanced heat maps. There is the basic heat map function in R as well that we can use. We need to install this package first of all. And what we're going to do is create some simple data, looking at the numbers from 1 to 200. We're going to add some variation into that using the rnorm function with values with a mean of 1 and a standard deviation of 20. So it's a big spread of values there. So if we add these together and set that for YY, you can sort of see YY has a kind of a wider distribution. And what we can do is put this into a matrix called XX. And that's a 10 by 20 table of this vector. So if we look at XX and look at the dimensions, we can see that it just contains different values that we can plot. So with base R, we just have a function called heatmap. And if we give that XX only, it'll plot it like straight away like this. So you can see that's printed on its own. Heatmap.to is a more handy function that's in gplots. If we plot that instead, we get a plot like this, which is a legend, for example, which is convenient to have. You can see we've got the dendrograms and the rows and columns. And you can see that these are partially sorted by their similarity. Of course, dendrograms are just using a simple version of bottom-up clustering algorithm, and there's a lot of nuances of how you might approach that. We can see that we have a basic heat map here, and we might want to, look at different features of it, including scaling the legend here that we see here, that it has just raw values that are very large, and it clearly is not normally distributed or anything like that. So what we can do is scale this by the rows, because they contain typically our samples. We want to normalize across the different samples to make them comparable to each other. So we use the scale function, scale it as a row. You can see that the colors kind of change. They're more spread across the red-yellow axis, making it easier for a viewer to view. And you see that we still don't have normalized, the data is not still quite skewed. But and the dendrogram structures are the same, of course, but it might be more easy to interpret the colors for the viewer. So what we can do is change this to any color scheme we can. So there's a function called color ramp palette, which has different colors there. So we can change this to whatever colors we want. There's a few examples down here. You can give them by the color names, like red and pink in our example here, or just give the code as well. That might be of interest. So if we look at this, we'll go from this color to pink. We kind of get this blue to pink spread of colors. And we go from 256 down to very few colors if we wish, as well, if we want to bin the colors to make it more simple. We can change this as well and go from red to blue as well. And what we're doing here is turning off the trace line. So you see there's a trace line that's printed there. So that trace line, so we're in this part here, if we plot that with a hash in front, you see the trace lines are gone now, so it's more clear to see what's going on. What we can do as well also is toggle the key to be false, so that this trace line and the whole legend is removed now. So you may want that on or off. It's up to you. You can toggle that in this way. So now I've kind of gone for different color schemes. So we could try, say, yellow to blue as well. There, so you've got quite a different color scheme. Maybe that shows more of the subtleties than red to pink, which is not the best color scheme in the world. So you can try your own, make your own data and create your own color scheme. For example, it could be blue tone or whatever you want. So what we can do as well is toggle some of these other features. So there's a few things going on here. Firstly, we have our heat map. So we turn on row and col NA, that is going to turn off some of the features associated with the labels for the rows. So you see that's gone. And the dendrogram is is set to be false. So if we change these around and use row v equals NA and lab col equals NA, these will disappear as well. So you see they're gone now. We're turning off the having no X and Y axis labels. We're turning the colors, maybe red to green, red to blue is probably better. We're sending the dendrogram to be none, and let's try that on its own. So you got a plot like this, and what we're going to do is add on row and side colors. So we may have annotations that we want to add from our features across the columns and our samples on the rows. So arbitrarily, they're just going blue, orange, green, purple, gray here twice. And then for the features, they're going from dark gray to light gray. Again, that's just arbitrary to show that you can add on these row and col side colors onto your diagram to make it more relevant as you see fit. And we can toggle some of these to turn them off and return it to more like its original shape there. We turn off keep the legend as well. So you can see that that's also quite possible. So we can change this with different colors as well. So this one is with a different color scheme using HCL colors palette. So you can see that there's a different set of colors there. So what we can do with ggplot and heat maps is structure the data in a different way. So we need 2 dimensions for our labels. So we need firstly one column with one label and a second column with another label, and then put the values after that. So it's kind of like long data. So here we have the letters 1 to 20. So that's A down to T, and then we're pasting together var and a sequence of the numbers 1 to 20. So again, we have more labels, var 1 to var 20. What we're going to do is put this into data. And if we view data, we can see that we have kind of a grid of these 2 layered together, and there are the different labels created there. And we're adding in another column Z into that table to get into values for each of these entries. So Z are our values, and you can see this is like long form, tidy data. So then we can take our data and say the aesthetics as our X and Y. So X equals X and Y equals Y is what we're saying. And then we're saying to fill that with Z. So the magnitude of the intensity of Z will tell us what that value is like. So if we did that on its own, we got to get this blank canvas, and then we can add GM tile on top of that. So you can see there we have our values mapped onto that, and then we can scale the gradient from white to blue if you want as well to toggle the colors in a particular way. But that can be any colors, and we can change that colors to different palettes. So it could be red, purple as well, as you can see there. So to understand it better, what is suggested is that you create your own tabular data and create a heat map with your own side colors for the rows and columns, and tweak the parameters to see how well it works for you. So we'll talk about more in class if you have any questions.